Example 2, real world problems. So for part A is a sledding run is 300 yards long with a vertical drop of 27.6 yards. So find the angle of depression of the run. So a sledding run is 300 yards long with a vertical drop of 27.6. So I know my vertical drop is 20.7.6. Now for a sledding run, sledding, you go downhill. So our downhill is going to be 300 feet long. And then I want to find the angle of depression. Remember, angle of elevation or depression is always going to be this angle over here. So what I want to do is find our angle. So if this is the angle we're looking for, the 27.6 is going to be our opposite. And then this is going to be our hypotenuse over here. So we refer back to SOHCAHTOA. If we got opposite hypotenuse, that goes with sine. So sine of our angle equals our opposite over our hypotenuse. We're just going to sine inverse both sides. So then we get theta equals sine inverse of 27.6 over 300. So let's see what that is. Sine inverse of 27.6 divided by 300, we get 5.3 degrees. So our theta equals 5.3 degrees. All right, part B, the angle of elevation of the sun when a find the angle of elevation of the sun when a 12.5 meter tall telephone casts a shadow that's 18 feet long. But remember, shadows are always on the ground. So we got this angle we're looking for. This is our opposite. Now we got on our adjacent. So if we got O and A go with tan. So we get tan of our angle equals our opposite over our adjacent. So we're going to do tan inverse. So our theta equals tan inverse of 12.5 over 18, which equals, so 12.5 over 18, so it's about 34.8. degrees. Part C, a ladder is resting against the outside of a house. So we got something like that. The ladder is extended 18 feet and the base of the ladder is 10 feet from the, let's just say wall again. Wall. What is the approximate angle formed between the ground and the ladder? All right, so we're looking for that angle. So if we're looking for this angle, we got our adjacent and we got our hypotenuse over here. So A and H, scroll up, A and H go with C for cosine. So we got cos of my angle equals my A over my H. We're going to cos inverse both sides. So now we get theta equals cos inverse of 10/18. So cos inverse of 10 over 18, and we get 56.3. So 56.3 degrees. And finally, last one, a 40-foot high tree casts a shadow 58 feet in length. Find the measure of the angle of elevation. So that's going to be, again, be that side. So we got opposite and adjacent. So OA go with tan. So tan of my angle equals opposite over adjacent. We're going to tan inverse that. So we get theta equals tan inverse of 40 over 58. 40 over 58. That gives us 34 or 34.6. So 34.6 degrees.